Okay, good morning. Welcome to
FamilyMath433.
FamilyMath433. So we got this book a while ago called The Puzzle Universe. And you were kind of flipping through it, and I asked you what we were going to do today, and you said, what did you want to talk about?
The random walk.
Random walks. And so you learned about it in this book, and hopefully I have it marked correctly. So here we go. Is that on screen, at least sort of a little bit?
Yeah.
So it's 211 and 212. So 211 is random walking on a line.
Yep.
And we'll look at that first. And 212 is random walking in a plane. So we'll look at that second, okay?
Okay.
So what we're going to do... By the way, do you like this book?
Yeah.
Oh, it's the first time we've done a project out of it, so I'm happy. So what we're gonna do is we're gonna pretend we're gonna mark something as the origin here, and we're just gonna use a line right here. So if I go +1, I'm gonna go over to here.
Yep.
-1, I'm gonna go over to here.
Okay.
Okay, but I'll leave the yellow as the
Star.
marker, and we'll use an orange tower as our walker. Okay. So what we're going to do is, you're supposed to flip coins, but coin flipping never shows up very well on the camera. So instead we're going to roll a die. And how will we turn rolling a die into a coin flip?
Maybe odds can be heads and evens can be tails.
Okay, odds can be heads. So which way do you want to go on a head?
Head can go up and tails go down.
Okay, so if we get an odd number, we go 1 to the right. Get an even number, we go 1 to the left.
Yeah, okay.
Okay. So shake it up pretty good, and then roll it. And then, all right. So what do we get?
Even tails.
All right. Okay. Keep going.
Even.
All right.
Odd. Odd.
Okay.
So now we're back here. Odd. Even. He just keeps going to go back here.
Okay. So that's an example of the start of a random walk. So I'm curious, what do you guys think a random walk is ultimately going to end up looking like?
Well, I think ultimately, if you did this forever, you'd probably end up back here.
And
Like if you roll the dice infinite times,
Uh-huh.
I think you'd end up back here.
we're already back here.
Because we have the after the infinity times, you'd be back here. Because the dice, if it's a completely fair dice and the roller is fair,
Uh-huh.
we should end up back there.
Why?
Because half the time we're going to go here, and half the time we're going to go here.
Okay.
So that should all average out to put us in the middle.
Okay, interesting. So what do you think is going to happen after a long, long time? Or what do you think this walk is going to end up
I mean,
looking
if
like?
you roll it infinite times, and it's eventually going to go back here if you stop when it goes back there. But not
Oh.
a finite number of times.
But not in a finite number of times. Okay, so where do you think where do you think you might walk to?
Well,
I mean, like, if we just rolled it once, you could just go to there.
yeah, but like, if you just kept rolling it and you keep going like back over here, and then you'd eventually get back to here in a finite number of rolls.
Okay. How far away do you think you can get from 0? How far away do you think you get?
That just really depends on chance.
Uh-huh.
Because like, you just had no even numbers for 10 rolls.
Uh-huh.
You could just get that far away, but it's just all a matter of chance, because sometimes you just go 1 and then even pulls you back there.
Okay. Well, so what I did is I wrote a little computer program on Mathematica that we'll take a look at, because it's hard to flip, or it's hard to roll 100 dice and just see where we go. Okay?
Okay.
Let's take a look at the program.